So, hi guys, welcome to lesson 4 in geography series. Today we are going to learn about plate tectonics. In previous class, we have talked about continental drift, uh, convection current theory by Arthur Holmes, and seafloor spreading. Okay, seafloor spreading by Harry Hess. So, based upon the convection current theory and seafloor spreading theory, a geographer called P.J. Morgan. P.J. Morgan has developed a concept called as plate tectonics. Okay, so what is plate tectonics? Um, Plate tectonics means it is the whole mechanism or the whole action of uh, evolution of plates, nature of plates, motion of plates, and the resultant reaction is together called as plate tectonics. So, what is plate tectonics? The evolution of plate, okay, nature of the plate, and action of the plate. Due to its nature, evolution, nature, and action, there are certain reactions to it. So, these together called as plate tectonics. And now, so what is a plate? In previous class, we have learned that plate means crust plus upper mantle or top layer of mantle. It is called lithosphere. This lithosphere is nothing but plate. Crust plus upper mantle is called lithosphere. This lithosphere is otherwise also called as a plate. Okay, these plates plate is a part of the continent. Okay, the plate is not something a separate part. It is part of the continent. Okay, it is part of the continent, right? Due to this motion of the plates, continents move on the earth. Okay, and this movement of the continents is today's what we are seeing. The continents today what we are seeing is result of the movement of the plates. Okay, why these plates move? Due to convection current that's happening in the asthenosphere. Okay, oozing out, rising of the magma due to radioactive decay in the asthenosphere, resulting in the movement of the lithosphere. Okay, lithosphere is nothing but plate. It is part of the continent only. So due to that movement of the plate, either it's dividing or converging, continents either drift towards west or drift apart or drift towards each other due to movement of the plate. Okay, so this is what plate tectonics is, and this is what plate is. And now like characteristics of the plate. Okay, a plate, what is its definition? I have said the meaning of the plate, but we are going to learn the definition of the plate. Okay, plate is massive. It is a massive structure, first thing. Second thing, it is irregularly shaped. Okay, uh, and third one is it is either composed of either continental material or oceanic material. Okay, it can be either continental plate or oceanic. If you take a plate, if it contains the contents that are part of if it contains the contents that are more contents that are part of a continent, then it is called a continent plate. If it contains those contents which are more of oceanic contents, then it is called a oceanic plate. Okay, what are the constituents in a continental plate? Of a continent is Cl, that is silicon and aluminium, and that of oceanic is we call Sima, silicon and magnesium. If a plate contains more of Cl, it is called as a continental plate, and if it contains more of Sima content, it is called as oceanic plate. Okay, this. And moreover, density of the plates. Oceanic plate is more denser than continental plate. Why? I have explained in the previous classes why oceanic crust or continental crust, the density varies in thickness, why it varies. I have explained it. Okay, oceanic plate is more denser, continental plate is less denser compared to oceanic plate. Okay, this is what definition of the plate. Okay, and next, and this thickness of the plate ranges from, if it is continental, the thickness ranges from 5 to 100 km. If it is oceanic plate, sorry, if it is continental plate, the thickness will be around 200 kilometers. Like we said, it's massive, right? See, its thickness itself is 200 kilometers. And if it is oceanic, the thickness varies from 5 to 100 kilometers. Okay, and next part would be, and based upon this movement of the plates, scientists have divided these plates into major and minor. Okay, there are in total 7 major plates and several minor plates. Minor plates are many in number, so you need not worry about remembering all those minor plates. We have to remember only few of the important minor plates, like Nazca, Arabian plate, and so on and so forth. Okay, and map of this plates is given in your NCR textbook itself. So it's a very good illustration about the plates. And while I'm explaining this, you look into that map so that you will get a clear understanding about what to study or what not to. Okay, and yeah, I will show you a map here. I think it's clearly visible to you. Yep. Wait a minute. Give me a minute. Okay. Yeah, it's clear, right? Hmm. You can either see in physical geography NCERT 11th class or in your atlas also. Okay. Now let us, yeah. See, we have learned that there are total 7 major plates. Okay, what are those 7 major plates? Antarctic plate and its surrounding ocean. Antarctic plate and its surrounding ocean. Okay, and next is North American plate. Okay, North American plate, and it is separated from Western Atlantic floor. Okay, it is separated from Western Atlantic floor by Caribbean plate. Okay, North American plate, it is separated from West Atlantic floor through Caribbean plate. Okay, I mean by Caribbean plate. Third one is your South American plate, and it is separated from North American plate through a Caribbean plate. In between, South American plate is separated from North American plate. So with in between, I mean, like, with the Caribbean plate. Okay, South American plate. And next major plate would be Indo-Australian plate, or India, Australia, New Zealand plate. Okay, Indo-Australian plate or India, Australia, New Zealand plate. Okay, and African plate. And finally, we have Eurasian plate. So total, how many we have got? Antarctic plate, North American plate, South American plate, Indo-Australian plate, Eurasian plate, African plate. Yeah, seventh one would be your Pacific plate. It is oceanic plate. Okay, so there are total 7 major plates and several minor plates also there. Many of them were not important. The most important would be Nazca plate. Okay, Nazca plate here on the west coast of South America. It is important because it was the reason for the formation of Andes Mountains. Okay, the ones that run through western coast of South America, Andes Mountains. Yeah, moreover, I forgot to tell you. In previous class, I have said that Rocky Mountains are on the eastern coast of America, I mean North America. As minute correction, they are on the western coast of North America. Okay. Uh, Nazca plate. Another important minor plate would be your Philippines plate. So the interaction between Philippines plate and Pacific plate resulted in many islands and trenches. We look into it, how they are formed. Okay. Yeah. And Cocos plate would be another important minor plate. Hmm? That's all. These are the important minor plates. And remaining minor plates that were mentioned in physical geography in your textbook, please locate them on the map. Okay. These are the major plates. Yeah. Now coming to uh, actions of the plate. Okay. So previously, Alfred Wegener, you remember him, the one who put forth the one who explained the continental drift theory, Alfred Wegener. According to him, continents are drifting. But if you look into it deeply after the post-drift studies, that is after convection current and seafloor spreading theory, scientists came to a conclusion that it is not the continent that is moving; it is plate that is moving. As a resultant, the continent is drifting apart. Okay, it is these plates that are placed beneath, beneath the continents. That is the this lithospheric part. Yeah, it is itself is moving. Okay, it is not that I mean continents are moving because of the movement of these plates. These continents are drifting apart. Okay, and yeah, and another thing is that. Alfred Wegener said that several millions of years back, all the continents were yeah, in a single unit mass called as Pangea, and later drifted apart. Okay, but scientists later, due to modern era research and studies, scientists came to know that these continents, yeah, they are together at some point of time, but this togetherness or being in a single unit is not as said by Wegener, but they are in a certain way. This unification is in certain way at certain points of time. Okay, if you look in your physical geography textbook, there were certain illustrations in some figure 4.4 or something. In that illustrations, it was clearly given how those continents were during in 540 million years back to present. Okay, like 540 million years back, India, Australia, Antarctica, they were all together. At present, they were all separate. So there's a chronological order in that. You no need to remember it. Just for your clarification, just look into it, give it a glance. That's all. Okay. The important thing here is, yes, they were unified at certain point of time, but that unification was not as said by Alfred Wegener, but it is something like that is given in that illustration. Okay, please look into it. Yeah, and they were drifted apart due to movement of these plates. Okay, and how scientists came to know that how scientists drew that unification 540 million years back, earth was like this, 120 million years back, earth was like this. It is based upon the paleomagnetic data. What is paleomagnetic data? Okay, in previous classes, like while I'm teaching about seafloor spreading, okay, uh, I have taught you one thing, that is about the magnetic field of the rocks. Okay, um, Earth has certain magnetic field. Okay, this magnetic field varies due to many conditions in the universe. According to those anomalies in the magnetic field, the magnetic anomaly in the rock, okay, that it can be either towards north or south, or it can be either positive or negative. Just remember that it can be either north or south. So, based on this paleomagnetic data of the rocks, that is the magnetic property of the rocks, scientists came to know that yeah, they were in either at South Pole or at North Pole. Okay, uh, it is paleo because the data was from ancient ancient data. I mean, those rocks are ancient rocks. The magnetic properties of those ancient rocks was studied. So it is called as paleo. Paleo means ancient. Okay, we have Paleolithic sites in ancient history, right? Paleo means ancient. Something that is very primitive in nature is called as paleo. So paleomagnetic data, that is the paleomagnetic property of those rocks were studied in different continental masses, and they came to know that yeah, at 500 million years back, this rock was at the south pole. That means this continental mass was at south pole. Later, the magnetic anomaly of those rocks has changed towards north. Let's say at 120 million years. And they came to know that yeah, 120 million years back, this continental mass was at north. Okay, okay. So based upon that, they drew a map from 540 million years to present. Please look into it. It is based upon paleomagnetic data. And another fact is that the paleomagnetic data of Indian subcontinent was took from a city called as Nagpur. Rocks from Nagpur were taken, and paleomagnetic data of rocks from Nagpur was studied, and scientists came to know that yeah, Indian subcontinent was at South Pole during 50 million years ago or 120 million years ago, and at present it is above equator. Okay, this is how the ancient map of Earth was drawn based upon paleomagnetic data. And with respect to Indian subcontinent, this paleomagnetic data of the rocks was taken from a city called as Nagpur. Okay, yeah. Let's get into this action of plate tectonics. Okay, I have said in convection current theory that no, sorry. Radioactive elements. Due to this decay of the radioactive elements, heat is emanated. Heat. Due to the heat, this is magma. Magma rises, and this is your plates, lithospheric part. Okay. Due to rising of the magma, it hits the continent plates and diverges. Okay, and develops cracks here, right? Uh, it hits and diverges, and it comes into contact with another magma from another continental plate. Here it comes into contact with here. Okay, if you look into it, there is divergence happening here, and there is convergence happening here. Okay, convergence, right? Wait, and divergence. Sorry. It is convergence, and it is divergence. Okay, due to rising of the magma, as it hits the continental so not continental plates, those plates either diverge or converge. That means plates can move towards each other, or plates can move away from each other. Okay, and also there is a special condition called as transform plate, wherein um, here it is horizontal action. Okay, but when it comes to transform fault or transform boundary, we call it is called as convergence boundary and divergence boundary, and third one is transform boundary. When it comes to transform boundary, plates move vertically. Okay, if this is the plate, what happens in a transform boundary means these plates slip against each other. One moves down and one moves up. If it is like this, they strike like this. Okay, one of the plates slips down and another plate will rise up like this. Okay, this is called transform boundary. It is a vertical action. When it comes to convergence and divergence, it is horizontal action. They will either converge or they will either diverge due to action of the magma. It hits and they diverge or converge. So, what is the resultant action of the this movement of the plates? There are three actions. It is divergence, convergence, and transform. Okay, let's look into each of these actions, and we'll talk about how major major physical features of the earth are formed, like how mountains, rift valleys, islands, trenches are formed. We'll look into it. First one, we'll go for convergence. Okay, what are the features of convergence? Its action is horizontal. Okay, first thing. Second thing, it is destructive in nature. Why it is convergence is destructive in nature means, uh, uh, while there is convergence of the plates, one of the plates, the denser plate subsides down. We have talked about it in previous class while explaining sequence spreading. Okay, the denser plate will subside down, so that while subsiding down, we can see that there is a consumption of this plate. Okay, this lithospheric part or plate gets subsides down, the denser one gets subsides down. So we can say that there is consumption of this subsiding part. As there is consumption of this subsiding part, subsiding down of this denser oceanic plate, we can say that convergence is destructive in nature. Okay. Here, crust is destroyed. Why it is destructive? Crust is destroyed because the denser crustal part subsides down into magma. So it is destroyed. So it is convergence, plates convergence is destructive in nature. Okay, and moreover, this convergence can happen in three ways. We look into it. First one would be ocean continent convergence. Ocean continent convergence. Okay. I forgot to say, while explaining this plate tectonics, make sure you have your atlas beside you. So that I will name certain places and you locate them on that. Okay. Majorly, you should have one, your atlas. Secondly, your physical geography textbook, where there is map of these plates. Keep them with you while watching this class, while running, while making your running notes. Make sure you keep those two with you, and locate the places while I am telling them. Yeah. Okay. So this convergence can happen in three ways. First one is ocean continent convergence. Okay, that is a continent and a oceanic plate. Wait, if this is oceanic plate, above this oceanic plate there is ocean. Above this continental plate there is continent. Okay, there is continent here. This is plate. That's all. They are converging, moving towards each other. Okay, and what happens after this? They move towards each other, and as they come closer, the denser part, that is the oceanic plate part, gets subsides. Okay, it's subsiding down, subsides, and uh, it gets destroyed in the magma, and this magma rises through this continent by creating faults here, hits it and rises, right? While rising, it forms certain volcanoes. This magma hits the continental plate, make cracks in that continental plate, so magma oozes up, comes into surface as volcanoes. Okay. uh, so what happens when an ocean plate and continental plate gets converged? The denser oceanic plate subsides down and gets consumed into magma, and this magma again rises up through continental plate and forms volcanoes. Okay, and forms the volcanoes. Okay, and at this juncture where it is subsiding down, that is where this continents getting subsided down, we can see or observe, we can observe trenches being formed. Okay, trenches, the deepest part of the oceans. Trenches are nothing but it is a point where the oceanic plate is getting subsided into interior of the earth. Okay, it is a condition where this oceanic plate, while converging with a continental plate, the denser oceanic plate getting subsided down, and at the juncture trenches are formed. Through these trenches only this oceanic plate goes into interior of the earth. So that's why they are so deeper. Okay, those trenches. Okay, and secondly, we are saying, and again, what happens? So trenches are associated with convergent boundary. Okay, and we have said that this oceanic plate gets consumed and the magma rises through the continental plate and appears on the surface as series of mountains called series of mountains. They are volcanic in nature, and few geographers also call them as fold mountains. Okay, best example would be convergence. Best example for ocean continent convergence would be convergence of Nazca plate and South American plate. Okay, Nazca is a oceanic plate. South America is a continental plate. Okay, while they are moving towards each other. Okay, this South American plate drifting from the Africa, and it is moving towards Nazca. Nazca is moving towards it, and at the junction, Nazca plate is getting subsided down. Okay, so there is formation of Peru-Chile Trench in the western coast of South America, located on the map. Peru-Chile Trench. Okay, and the Nazca plate is getting subsumed into the interior parts of the earth. Peru-Chile Trench is formed, and the magma is rising from the South American continental plate, forms as a series of fold mountains called as Andes Mountains. Okay, if you look at western coast of South America, you can observe Peru-Chile Trench and Andes, a series of fold mountains called as Andes Mountains. Okay, this is ocean continent convergence. Second one would be ocean convergence. Ocean convergence, where two oceanic plates move towards each other. Okay, it is ocean convergence where two oceanic plates move towards each other. So what happens next? When they move towards each other, the denser plate will subside down. Yeah. And another thing is, make sure you draw these diagrams in a neat manner in your notes. I'm very bad at drawing. So, but the illustration is clear, right, for you. Make sure you draw this in, in a clear way in your notebook. These illustrations are very much important. Like when you're revising, if you, it would be much easier to learn from these images itself. Okay, it's a quite complex topic, but once you revise it or revisit the classes once or twice and you master it, it is really easy. Okay, so yeah, where were we? Two oceanic plates converging. The denser oceanic plate subsides under the what we are saying, subsides under the into interior of the earth, and at that juncture we can see formation of trenches, and again the magma rises here from the through that oceanic plate, which is above it, which is on the like the lighter oceanic plate. Thus, the denser one is subsuming down, and the lighter one is on the top. And the magma is rising from this oceanic plate, which is on the top, and hitting the making cracks in that oceanic plate, and appearing as volcanoes on the surface, on the oceanic surface. Okay. So what's happening due to constant hitting of the magma? These volcanoes rise above, and this rising is in such a way that they rise above the water, below the ocean. They are volcanic mountains only. We call it volcanic mountains while they're in below the ocean. Okay, due to constant hitting of the magma, what's happening? Constant hitting of the ocean, this oceanic plate by magma. These volcanoes are rising upwards, and at certain point of time they are above the oceanic surface. Okay, while these volcanic mountains, while the submerged volcanic mountains rise above the oceanic surface and they're present on the oceanic surface, they are called as islands. That is how islands are formed. Okay. What did Alfred Wegener said about the formation of islands? Due to limiting factor of the tidal force, the drifting was not proper, and certain parts of the continent remained as islands. He said that. So it's completely wrong, and this is the actual reason for the formation of the islands. The islands are nothing but they're volcanic in nature only. Okay, we constantly see news about the volcanic eruptions in Japan, in Hawaii. Why? They are volcanic in nature. They are formed by the oceanic convergence, ocean convergence, and this subsumed volcanic mountains rose above the oceanic surface due to constant heat of the magma, and while they are on the surface they are called as islands. Okay, this is what ocean convergence is. So what are forming in oceanic convergence? Trenches are formed. The denser plate is subsuming under the lighter plate. Trenches are formed, and this subsumed magma rises from the lighter oceanic plate. Volcanic mountains are formed. Series of volcanic mountains are formed due to constant hitting of the um magma. This series of volcanic mountains rise above the oceanic surface, and when they are visible, when they are at the visible part of the oceanic surfaces, they are called as islands. So while you go to Hawaii or Andaman, while you're standing on the island, please do remember that it is a volcano. It is a volcano, and there is ocean beneath it. It's actually a subsumed part of the ocean, and due to constant heating of that, it is rising above the ocean. So okay, this is how islands are formed. So, and next, the best example for ocean convergence would be convergence between um, Philippines plate and Pacific plate. Okay, you look at these two plates in your geography textbook. If you see it, the Philippines plate and Pacific plate will be there. They move towards each other, and trenches are formed. You can see Mariana Trench. You can see Java. What you say? Like yeah, Java Trench. Okay, and the series of islands: Philippines Island, Sumatra, Java, Japan, Caroline Islands, Tonga Islands, Hawaii Islands. Okay, they all are nothing but volcanic mountains that rose above the surface. Okay, due to convergence of Philippines plate and Pacific plate, we can see series of islands over there. These, okay, series of islands and trenches in that region, Pacific region. Pacific one that is between if this is Asia, that is eastern coast of Asia, where it is Russia, Japan, China, and it is western coast of America, where there is Alaska, Rocky Mountain, California coast. In between there is what uh, what I'm saying, uh, Pacific Ocean is there. So due to convergence of Pacific and Philippines plate, there are a series of islands formed over there, right? Java, Sumatra, Brunei, Philippines, Fiji, Caroline Islands, and Mariana Trench, Java Trench, Japanese Islands. Okay, this is about ocean convergence. Next, continent convergence. Third one. Generally, when a continent converges, give me a minute. Generally, when a continent converge, there will be a ocean between them. Okay. For example, would be India converging with Eurasian plate. In between there is Tethys Sea. Okay. So what happens? It is a continent. It is a continent. In between there is sea. And what does the sea contains? Sediments from continents. These are sediments. Why sediments are formed? Due to running off of the rivers, due to rainfall and certain other climatic factors, the depositions on the earth move towards the ocean and they sediment. These are depositions from the continent, sediment in the ocean. So sediments are formed. So what happens when a continent gets converged? These sedimentary rocks, while it is converging, okay, while uh, let me explain. Continent continent converging, what happens? The depositions in the sea, these are depositions in the sea, while they are converging, just imagine, while they are converging, there is if it is the deposition, there is convergence from this side, there is convergence from this side. Due to that constant pressure, these rise above as mountains. Okay, like this is the sediment, and it moves like this and forms a series of mountains called as fold mountains. Okay, why? There is pressure from both the sides, they're compressing those sediments. So these sediments compress due to those that high pressure. This sedimentary rocks convert into metamorphic rocks. Okay, and these metamorphic rocks rise above as fold mountains, like v-shaped mountains. Okay, fold mountains means how fold mountains will be there? They will be like this. Okay, due to convergence from this side and this side, these the sediments from the ocean rise as fold mountains. Okay, and next, okay, let's look into it. Let's look into what continent convergence is. So yeah, there is continent converging. What happens in the next stage? While these are converging, in between them, these oceanic sediments rise above as fold mountains. Okay, And yeah, and this is how it looks like. Continent plate, and moreover, the denser continental plate will subside down. Okay, it is subsiding downwards. Okay, and in between them there would be a series of folded mountains. The best example would be convergence of Eurasian plate and Indian plate. Okay, so think like this: it is Eurasian plate, and sorry, it is Indian plate which is in the south. Eurasian plate, they are moving towards each other. In between them there is Tethys Sea with depositions. Okay, while they are moving towards each other, the sediments are compressing. Okay, the sediments are compressing and they rise above as Himalayan mountains. The Himalayas today we are seeing, they are nothing but deposition from the Tethys Sea. Okay, there are even certain newses, not newses, news that there are fossils found in Himalayan sea, um, the marine fossils were found in Himalayan mountains. How marine fossils were found in Himalayan mountains? Because once upon a time, these the contents of the Himalayan mountains were nothing but depositions in the Tethys Sea. Okay, so that's why. So the sea depositions got compressed and they rose above as folded mountains. That's why we can frequently see in news that there are marine fossils were discovered in Himalayan mountains because they are nothing but depositions from Tethys Sea. So Indian plate and Eurasian plate are converging towards each other, and uh, series of fold mountains were formed. These series of fold mountains were nothing but Himalayan mountains. Okay, and the denser plate is subsiding down. Here, the denser plate is Indian plate. Indian plate is subsiding down, and in between, Himalayas were formed. Okay, this is one thing. Another thing is, while Indian plate is moving towards the Eurasian plate, uh, there is convection current below the plate. Okay, and the magma is continuously rising up. So this continuous rising up of magma created cracks in the Indian plate and they oozed out as volcano depositions. These volcano depositions are nothing but Deccan traps. Okay, we often say Deccan Plateau, Deccan Plateau. This Deccan Plateau is nothing but the magma that rose above the Indian plate during the convergence period, and this magma rose above the Indian plate, and they got deposited as, you know, traps is here. Traps means they got deposited as big blocks of volcano. The that magma rose above the surface, it got cooled down and solidified into Deccan traps. Okay, this happened while Indian plate is converging with Eurasian plate. So the Deccan plateau is nothing but the solidified magma is Deccan part, and it is the source for black soils in Deccan region, the mostly in Maharashtra and Madhya Pradesh region. This like magma, this solidified magma, like these Deccan traps, were the source for black soil in those regions like Maharashtra, Madhya Pradesh, and north part of Telangana. Okay, so this black soil is good for cultivating cotton. So we can see more cotton cultivating regions in north part of Telangana, in Maharashtra and Madhya Pradesh regions. Okay, black soil. It is nothing but solidified magma. This how this solidified magma came. It came through constant hitting of the Indian plate. It developed cracks in the Indian plate, rose above those plates, and deposited on the continental part. As it rose above the surface, it got cooled down and solidified as Deccan trap. So you have learned how Himalayas are formed. You have learned how Deccan traps are formed, and you have learned continent convergence. The best example for continent convergence was convergence of Eurasian plate and Indian plate. This is what convergence boundaries mean. Wait, give me a minute. I can't find my pencil. Where is? Did I keep it? So we are done with convergence. Now let's look into divergence. What is divergence? Two plates are moving away from each other. Moving apart. So it is a horizontal action, and it is constructive in nature. Why it is constructive? Here, why new crust is formed. So that's why it is constructive in nature. New crust is formed. How new crust is formed? While explaining seafloor spreading, we have talked about mid-oceanic ridges in Atlantic Ocean, right? What did I say? Uh, the magma oozing from the this oceanic plate, coming out from the ridge and getting deposited on the oceanic bed, and creating new crust. Okay, creating rocks. We have talked about rocks, right? Those rocks part is nothing but their crust, oceanic crustal part. Okay, so this magma is hitting the oceanic plate, coming out, magma coming out as lava from these oceanic ridges, and there is formation of new crust. So that's why in divergent boundaries were called as constructive boundaries, because new crust is formed here. Okay, horizontal, constructive, new crust is formed. And okay, yeah, divergence happens in two ways. The first one would be continent-continent divergence, where two continent plates diverge from each other. Continent-continent divergence. Okay, this is one continental plate. This is another continental plate. Okay, they diverge from each other. Why? The magma rises, hits it, and it diverges. Due to this divergence, the continent plates also move away from each other. Okay, and what happens next? As it hits, develop cracks and forms a series of volcanic mountains on the continental part. Okay, it forms a series of mountains or volcanoes. These cracks, I am saying cracks. They are also called as joints. Okay, please don't get confused with the terms. You come across many terms like cracks, joints, faults. Okay, shear. They all are same. Okay, please don't get confused. All are same. Joints or cracks are developed, and the magma comes out as volcanoes. Okay, the rising magma comes out as volcanoes, and afterwards, due to that constant hit, okay, as the rising magma is hitting constantly, and due to that, this middle block where the constant hitting is happening, it subsides down. Okay, it subsides down. Where there is constant, there are two continental masses, right, and there is constant hitting of the magma. Whenever there is constant hitting, the region that is getting constantly hit, that is this blue color part, uh, cracks were developed, it becomes weak and subsides down. Okay, and this is how it looks. Okay, this is subsided part. This is the continent part. This subsided part where there is constant hitting is happening. Uh, we can, yeah, where there's constant hitting is happening, there is subsiding down of that block, and this is called as and some okay, there is subsided part, and these are two continental parts, and some scientists refer to these two blocks as block mountains. and in between two block mountains there will be a valley. Okay, the best example would be East African Rift Valley. East African Rift Valley, locate it on the map. East African Rift Valley. Okay, so how it formed? While uh, uh, okay, okay. Imagine this is South America. Okay, wait. Yeah. Imagine this is South America. This is Africa, and this is Indo-Australia, New Zealand. Okay, what's happening here? South America is getting drifted apart from Africa. Hmm? While drifting apart, South Atlantic Ocean is formed. Yeah, and Indo-Australian plate, it is moving towards Eurasia. It is moving like this towards Eurasia, that is towards north. While it is moving, so imagine Africa, Indo-Australia, New Zealand plate drifting apart. It is moving like this, like this. Okay, why there is constant hitting of the magma from the below, rising magma. It is getting drifted apart, and the middle block region, that is the Horn of Africa. Horn of Africa means eastern coastal part where there is Somalia, Kenya, Tanzania. Horn of Africa. We call it as Horn of Africa. Okay, the region in that Horn of Africa got subsided down, and a rift valley is formed. Here there are no block mountains. There are two continental mass. This African continental mass, Indo-Australian continental mass, drifting towards like this. This drifting like this. While this drifting is happening, the Horn of Africa got subsided, and a valley is formed. A valley is formed. Okay, and uh, um, consequently or subsequently, this valley got filled with rainwater. Okay, and we call it as Rift Valley. Okay, so the best example would be East African Rift Valley, and another best example would be Rhine Valley. Rhine Valley is in Germany. Okay, mm, like near Black Forest, I think so. Okay, East African Rift Valley. Locate East African Rift Valley in your atlas, and there are certain important lakes surrounding it, like Lake Victoria, Lake Malawi, and there is a desert also. I can't remember its name. Something starts with O, I think so. So locate those rivers also. Why this location is important means, when you're studying geography, either for GS or for optional, especially for optional students, this locating of places is very much important for you, because and it also helps you study international relations also. See, if you generally see, uh, uh, most of the international relations surround around the regions where there are high number of resources. It can be mineral resources, it can be water resources. Okay, or human resources also. So, and most number of coup means nothing but military annexation of a certain country. These also happen in the regions where there are most of the water resources are there in Africa. So locate those regions. It will help you while reading news. Okay, you can come across Lake Malawi or Lake Victoria. So you can remember about East African Rift Valley, how East African Rift Valley was formed. We have just learned that you are drifting apart of Africa and the Indo-Australian New Zealand plate. The Horn of Africa subsided. Certain part of Horn of Africa subsided down, formed a valley, and this valley got filled with rainwater subsequently, and formed a Rift Valley, East African Rift Valley. And there are certain important lakes surrounding it, the Lake Victoria and Lake Malawi. Okay, and there is further divergence. Okay, after so divergence that did not stop after the formation of valley also. There is there is further divergence. Okay, um, due to further divergence, this valley part also lengthens. Okay, this continental mass, it drifts apart. Give me a minute. Sorry for the inconvenience. Uh, okay, yeah. Further divergence happened. Okay, the valley also got lengthened, and so while this lengthening is happening, the valley got lengthened and it is further subsiding down. Okay, the divergence is happening and valley is also getting subsided down for frequently. Okay, so as it's subsiding down, 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 and down, the oceanic water beneath these continental plates rose above the continental plates and got filled up in that valley region, and a linear sea is formed. Okay, the best example would be Red Sea between Arabian plate and African plate. This Arabian plate is also part of Indo-Australian, New Zealand plate, and certain is from Eurasian plate. Okay, it is as I said, Africa, Indo-Australian, New Zealand plate, drifting like this. Okay, it is drifting like like upwards, and in between Arabia and Horn of Africa, we can see Red Sea and East African Rift Valley south to the Red Sea. Okay, drifting like this. Okay, further drifting happened. So the valley part subsided down and got filled with oceanic water, and a linear sea is formed. The best example would be Red Sea. Okay, yeah. As you move northwest to the Red Sea, you can see Suez Canal. Okay, look at it on the map. East of the Suez Canal, you have Jordan, Syria. Okay, look at them on the map. Yeah. Next, further divergence happened. What happens when there is further divergence? Continents, continents, oceanic water got filled. Okay, the magma is still rising, and they form as mid-oceanic ridges. Okay, the magma is still rising, and they rose into the oceanic floor as mid-oceanic ridges. From this mid-oceanic ridges, lava is oozed out and a new oceanic crust is formed. Lava is oozed out and new oceanic crust is formed. Okay, how the further image will look like? Continent. This is rock number one, rock number one. Okay, rock number one comes here towards the continent. Okay, another new rock is formed because there is mid-ocean due to mid-oceanic ridges. Rock number one, here it is continental plate. It is rock number two because it is new rock that is formed due to oozing out of the magma's lava. A new rock is formed. So we have learned in seafloor spreading that as we once move from mid-oceanic ridges towards the continents, the age of the rocks increases. The one we have named it as one. It formed before the second one. Due to further divergence, the previously found one got like drawn towards the continent, and there is a empty space here, like here at 2. That empty space is filled with rising magma. This rising magma came out from the mid-oceanic ridges, and a new crust is formed. So we can also say when one moves from oceanic ridges towards continent, the age of the rocks, that is age of the crustal part, increases. Okay, so through further divergence, new oceanic ridges are formed, new rocks are formed, and continents get separate further apart. and result in the formation of a big ocean. Best example would be formation of North Atlantic and South Atlantic Ocean due to drifting apart of North America and South America. Okay, in between them there are mid-oceanic ridges. So what happens when continents diverge? Initially, when two continental masses diverge, first thing what happens is uh, these oceanic mass, the rising magma hits the continental plates. Wait, what? Okay, the rising magma hits the continental plates, develops cracks in the continental plates, rises above as series of volcanic mountains. For this example would be Rocky Mountains. Rocky Mountains on the western coast of North America. Okay, locate it. Previously, North America and Europe were together due to rising magma. They drifted apart. During the constant hitting of the magma, cracks developed. They rose above the continent and formed a series of mountains called as Rocky Mountains. And after that, further drifting has happened. The one which is constantly getting hit subsided down, formed a valley. In certain cases behind beside the two valleys there will be blocks of continents. They are called as block mountains. Okay, uh, and for this the best example for us is in India, Narmada Valley. Okay, like this divergence can be localized divergence also. Best example would be for block mountains. Okay, Narmada Valley is best example for that block mountains. Okay, further divergence happened. Okay, further divergence happened and valley got deepened. It is getting subsided down and it is constantly getting filled with rainwater. Okay, this filling up of rainwater resulted in the formation of rift valleys. Best example is East African Rift Valley. Further divergence happened. After the Rift Valley, oceanic water started coming on into the valley and formed a linear sea. Best example is Red Sea. Further divergence happened. Okay, water got filled up, and due to further divergence, the magma rose above the oceanic crust and deposited on the oceanic floor as mid-oceanic ridges. Through these mid-oceanic ridges, the rising magma came out as lava and deposited as rocks on the either side of the mid-oceanic ridges. Due to further divergence, these rocks also got separated, and along with the rocks, continents also got separated and resulted in the formation of a huge ocean. Best example would be North Atlantic and South Atlantic Ocean. This is continent-continent divergence. And next, second one would be ocean divergence. So diverging of two oceanic plates. Okay, they are already oceans. Okay, they were together. Above them there is ocean. Constant hitting of the magma, rising magma. Okay, this middle part, this middle part would subside down. So how it looks. Okay, magma rises and forms a series of ridges. Okay, oceanic ridges like volcanic. They are volcanic in nature because it is nothing but the rising magma itself. Okay, the further divergence happened, and uh, what happens is through this new crust is formed. Due to oozing out of the magma, a new crust is formed, and a series for the divergence series of oceanic ridges, and new crust will be formed. Best example would be divergence of Nazca plate and Pacific plate. Okay, the divergence of Nazca plate and Pacific plate. While Nazca plate is drifting towards South America, Pacific plate is drifting towards Philippines plate, and Nazca plate is this Nazca plate is diverging from the Pacific plate and converging with the South American plate, and this Pacific plate is diverging from the Nazca plate and converging with the Philippines plate. Okay, and these two Pacific and Nazca plate are diverging from each other. So due to divergence, the middle part got subsided down. It got filled with oceanic ridges. Through oceanic ridges, magma oozed out as lava and formed series of rocks. Okay, the best example for this oceanic ridges that formed due to ocean divergence would be East Pacific rise. They are volcanic in nature. You can locate it on the map. East Pacific rise. It would be on the far west from the South America, west towards west of the South America. This is called East Pacific rise because they are found on the east side of the Pacific. Don't get confused when we say East Pacific and West Pacific. Pacific means what? Uh, this is North America. This is South America. This would be your Asia, and this is Japan, Philippines, and between there is Pacific Ocean. Okay. So when we say East and West Pacific, it would be West Pacific and it would be Eastern Pacific. So please don't get confused. Pacific means it would be on the west side of the globe. So it comes at the North America. East Pacific means it would be east side of the globe. So it would come at Russia or China. So don't think like that. If we say East or West Pacific, we are particularly talking about Pacific Ocean. So locate on the map where Pacific Ocean is there, and if you talk about West or East Pacific, it is with respect to Pacific Ocean. So where is East Pacific rise? East side of the Pacific Ocean, that is here. There would be East Pacific rise. As I told you, it would be on the a white patch because they are ridges. Ridges are depicted as white patches on the map or in your atlas. So locate East Pacific rise. It is best example for ocean divergence. Nazca plate and Pacific plate divergence results in what we say ocean divergence. Okay, we have talked about convergence, we have talked about divergence, and